Hi, my name is Alexey, an engineer from the Safari team. Today I'm thrilled to tell you about the HTML model element and how we are making it easier for developers to bring 3D content to the web across Apple platforms and beyond. Whether you're a web developer exploring 3D for the first time or an experienced 3D artist looking to bring your work to the web, I've got everything you need to get started. We pioneered the model element in VisionOS, a native HTML element that makes adding a 3D model as simple as adding an image. Now, the model element comes to iOS, iPadOS, and macOS. The same markup, the same element, works across Apple's platforms. Your 3D content reaches every Safari visitor, whether they are on iPhone on the go, on iPad at the coffee shop, or on Mac at their desk. You might be familiar with Model Viewer, the go-to JavaScript library for 3D today. It serves developers well, but the model element is native. No extra library, rendered directly by the platform, with built-in stereoscopic rendering on VisionOS. It's also an emerging web standard, so your code is future-proof. To reach all platforms across the web, a polyfill is available for browsers that don't natively support the model element yet. I'll cover that in more detail later. Let's say I'm working on an e-commerce platform for outdoor adventures, and I already have images for the products. Today, I'll walk you through adding 3D models to the product pages. First, I'll show you how to get assets ready. Then, we will dive into the model element, building up the experience one feature at a time. And finally, I'll show you command line tools to optimize models for production. Let's get into it. What if you don't have 3D assets in the first place? We recommend a Capture, Convert, Create approach, using your iPhone to scan real-world objects, converting existing files, or building from scratch in tools like Blender. But there has also been a revolution in generative AI, and with it an entirely new way to make the content you want. You can use images to generate a model that matches a real-world object, or a text prompt for more creative generation. Apps like Tripo3D and Meshy AI are only a couple to choose from. My store already has a few products, but I want to add an essential, a camping mallet. I started with several images of a mallet, and after a few minutes, my model was ready to use. I exported it as a USDZ file. The model element supports USDZ, Universal Scene Description, zipped into a single file. It packages everything a 3D model needs: geometry, materials, textures, animations. Safari supports other formats too, but for the best experience, I would recommend starting with USDZ. It's time to put a model on the page. Now, the mallet is ready as a USDZ file. I'll cover different ways of presenting the model element. I'll talk about how to embed a model, know when it's ready to display, and handle fallbacks. How to match the model to my page design, let visitors interact and explore. I'll guide you on how to implement custom transforms and play animations, and bring models into the real world with AR Quick Look and spatial computing. Okay, starting with loading a model. Just like image tag or video tag, you point model tag at a file with the source attribute, and the browser handles the rest. No plugins required. You can also use the source tag with a specified MIME type. Again, the same pattern as video tag. It's also important to think about fallback. The simplest approach: place an image tag inside your model tag. Older versions of Safari and browsers that don't yet support the model element will render the image instead. Your visitors still get an idea of the product, 3D models can be tens of megabytes or more in size, so it can take a while to load. The Ready promise lets you know when the model is actually loaded and ready to display. While the model is loading, it's a good idea to provide a visual cue, like a spinner. Hide it when the Ready promise resolves. And if something unexpected happens, handle it in the catch block and show your fallback content. You can also polyfill the model functionality as well. A polyfill retrofits the API of a new standard via JavaScript, letting you use modern features even before they land on every platform. The model element samples at the W3C show an example of exactly this. If the native element isn't defined on the window, they load the polyfill library to fill in as much of functionality as they can, as close to the native API as possible. Just make sure to test the functionality of both the polyfill and the native element. And remember that some features of the element cannot be polyfilled, such as the stereoscopic display on spatial platforms like Apple Vision Pro. The model element is rendered in its own virtual space, so it won't pick up the page's background. To match your page design, set background color directly on the model. Keep in mind, the background is always rendered opaque. Even if you specify a color with transparency, it will be converted. Now we have a model loaded and integrated into the existing page. Giving our visitors an option to interact with it is a natural next step. Let me show you how easy that is. The stage mode attribute with value orbit lets your visitors rotate the model freely side to side. And if they tilt it up or down, it gently sprints back to its original angle. Interactive, but always looking its best. The attribute also makes the model slightly smaller. It's rescaled to ensure no parts get clipped during rotation. Sometimes you want to add custom interactivity to the experience. The Entity Transform property lets you set exact viewing angles via JavaScript. And I'm going to add two buttons to show how it works. One for side view and a reset button to bring the model back to its original orientation. To use Entity Transform, you'll need to disable Orbit. Either remove Stage Mode attribute or set it to none. When you transform the model manually, parts of it may get clipped or even disappear if rotated out of the visible area. You might need to adjust the position to make it visible. To implement a transform, I create a DOM matrix. This represents the model's orientation in 3D space. Then call rotateSelf to define the rotation. Here we are rotating 135 degrees around the y-axis to get the side view. Finally, assign it to Model Entity Transform to apply the change. Capture the initial transform up front, then use it to reset the model back to its original orientation. The view switched instantly from one to another. To make the transition smooth, you can animate the rotation with Request Animation Frame. First, set up the state, the current angle, the animation duration in milliseconds. 500 gives you half a second, which feels snappy but smooth, and a reference to cancel any in-flight animation. The Animate 2 first cancels any running animation so transitions don't conflict, captures the current angles as a starting point, and marks the start time. Then I add the step function. On each frame, it computes how far along the animation is it the rotation for a smooth finish, and updates Entity Transform with a new DOM matrix. While animation is still running, it requests the next frame. Finally, assign Animate 2 calls to the buttons. Side view animates to 135 degrees, reset to 0. Let's see it in action. When a user taps Side button, the model smoothly rotates to show the side view. After tapping Reset, it glides right back to where it started. Custom transforms and animations give you full control, but they require extra work. Bounding boxes, clipping, manual animation code, If your use case allows it, the Orbit Stage Mode gets you interactive 3D with a single attribute. Choose what works best for your product. Models can also come to life with built-in animation. These animations are typically authored in 3D tools like Blender or Maya and baked into the USDZ file. The model element plays the first animation track, and with a couple of lines of JavaScript, you can control the playback rate, or even run it in reverse by providing a negative value. To do that, I implement a simple play function that sets playback rate on the model and calls model's play method. That's it. A positive value plays forward, a negative one reverses it. Here I'm using 5 and -5 for a faster playback. So far, the store visitors can explore products in 3D right on the page. But what if they want to see how it looks in their environment? Wrap a model in an A tag with rel equals AR attribute. Point to the same resource. And on iOS and iPadOS, your customers get a full AR quick look experience. On VisionOS, the model element was already making 3D content feel like a natural part of the web. With stereoscopic rendering, models gain real depth. Your customers can pull the product out of the page and examine it as if it were right in their hands. VisionOS also supports immersive website environments, which use the model element and let you transport your audience right inside the scene, all from Safari. If you want to learn more about this feature, be sure to check the Explore Immersive Website Environment session. It explains the API in detail. With the assets ready and the model elements in place, let's see it all come together. Here's our catalog page with 3D models. And the interactive exploration is my personal favorite. Your customers can rotate, tilt, and view every angle of the product, exploring it in the way they want, all running right in Safari. Our product page looks fantastic running locally, but you may find loading can take a while over the internet. It would be great if we could get this model smaller. To do that, I'm going to run a command line tool called USD Crush on the boot model. And with no change in quality, the file goes from 7.9 megabytes down to 1.9 megabytes. That's crushing savings! When we open both versions side by side in Safari, they look identical. Same visual quality, significantly smaller file. If you have a 3D file, but no image for it yet, you can use USD Record tool to generate a thumbnail or a fallback image directly, specifying things like output format or rendering from a custom camera if there is one in the file. And unlike a screenshot, you can write a script. Well, who am I kidding? Your favorite LLM can write the script to run it across your entire catalog. Both these command line tools are already installed on your Mac. They are part of a larger suite of tools for working with USD content. You can learn more about all of them and the overall USD ecosystem in the WWDC26 session, What's New in USD and Material X. The model element started on VisionOS, and with iOS, iPadOS, and macOS support, it's expanding across the Apple family, and we want to bring it to the web at large. Our team actively contributing to the model specification as a W3C. And we would love to hear from you. If there are features you would add or use cases we haven't considered, now it's a great time to share your feedback. Web standards are shaped by the developer community, and your voice matters. For 3D content in the USDZ file format, the Alliance of OpenUSD has published the full specification, a clear, vendor-neutral reference. The Alliance also provides conversion tools and resources to help you integrate USDZ into your existing content pipelines. That's the model element, from assets to production. Now let me tell you about next steps. Try to create a 3D model of your own using text-based prompts or images you already have. Add a model tag to your website, point it at a USDZ file, and see how it comes to life in Safari. Use the USD tools to optimize your assets. Play with it on different platforms and see how the element adapts. Join the immersive web community group at the W3C. Bring your use cases, your feedback, and your ideas. Catch up on the related sessions like immersive website environments. And for a deep dive into spatial web features, see what's new for the spatial web from WWDC25. I can't wait to see what you build. Thank you and have a great WWDC.